Hey, Smath here. Electron configurations 2. Another one in our series of electron configurations. This time we're going to fill them for ions. We have two different types of ions. We have negative ions, those are called anions. We have positive ions, those are called cations. I'm going to do 4 examples for you here, 2 negative and 2 positives. I'm going to do fluoride ion. Normally an atom would be fluorine. Because it's a negative, it becomes a fluoride. And fluorine usually has 9 electrons, but because there is a negative charge, I'm going to add 1 to it. I'm going to make this 10 electrons. Let's fill it up. 1s2, 2s2, 2p6. 10 electrons, done with fluoride. What about our sulfide? These are negative ions. If they're monatomic by themselves, they end in IDE. Doesn't matter whether it's -1 or -2. But as I look at sulfur, this is normally going to have S2 minus, should have, I'm looking, 15, 16 electrons in a neutral atom here. I'm going to add 2 electrons to that because it's negative. That's going to mean 18 electrons. Let's fill them up. 1s2, 2s2, 2p6, 3s2, 3p6. If I add up my superscripts, 2, 4, 10, 12, 18 electrons. This is simple as just filling them into the shell that they need. Now let's look at our cations, our positive ions. Sodium plus. Sodium normally is going to have 11 electrons to it, but because it's a cation, we've removed an electron from that. That means now it's only going to have 10. Let's fill them up. 1s2, 2s2, 2p6, 10 electrons. Looky there. What about magnesium 2 plus? Magnesium normally has 12. Because it's 2 positive, that means we've removed 2 negative electrons. That's the only kind of electrons there are. So we're going to have 10 electrons again. Now let's go 1s2, 2s2, 2p6. Holy cow, wait a second. These two have the same electron configuration. Is that legal? Yes. They can do that. As a matter of fact, there's a term for these. These are called isoelectronic. They have the same electron configuration. Are they the same thing? No. They have a different number of protons, a different number of neutrons, but they have the same number of electrons. That's going to affect their chemical behavior. We'll talk about that when we do chemical reactions. But I'm Smath. This is electron configurations of ions. I hope this video helped you.